We're here on the Beckhoff Bause at Hannover Messe 2019, and we present here our new integration of pre-trained neural networks and other machine learning algorithms into our machine controllers. So we can load machine learning models into our real-time system and maybe call them out of a PLC or other tasks. This is very brand new and outstanding for automation processes. Here we have an anomaly detection example. We show how we can detect anomalies on machinery on this very simple example, the fan. So we only trained support vector machines with good data, so only on a good fan, non-broke wings, and then we deployed the complete algorithm into our TwinCat system running on our controllers, and now we can change between non-damaged fan and damaged fan, and I can also manipulate here the air pressure flow. And what we can see then in the result of the graph is that once the non-damaged fan is running, everything is okay, so the support vector machine knows this data, everything is classified as 1, which means everything is fine. And now I just close the clamp here, and immediately our algorithm says, well, something is different, and I open it again, and I come up again, okay, it's good again. Now the fan is turning off, and in this situation I have no information basically. Now the broken fan is starting, and once it's running, then the algorithm tells me, well, really something is wrong, something is different. Only in the area between turning the damaged fan on and the other fan on, there is some area where basically no information content is coming. There is a switch in between okay or non-okay.